Good afternoon, students. So, whether my screen is visible, I am inaudible.
Yes, sir.
Okay.
Visible, sir.
Yes, yes, yes. So, uh, just wait. Okay. So, welcome to the module 43 in the IC engine subject. So, last class we discussed about the basic introductions, right? So, what is the GDI engine, right? We have seen some introduction about the GDI engines, right? So now in this class we are going to see about the combustion process in the GDI engine and the advantages and the disadvantages and the major characteristics that we can see in this class, right? So before entering the class, just we can recap what are the terms we discussed in the last class, right? So the modern technologies which is used in the IC engines, why? Because we are using the modern technologies, right? So why we have to develop a new technologies? Because of the three conditions, right? Because of the three conditions. That three conditions will be the fuel efficiency, right? So for the conventional, so the conventional engines uh, will require the more fuel to get an extreme power, right? For the conventional engines, conventional IC engines, but the modification, right? So the modification will be done uh, through some advanced technologies, right? Why? Because the fuel efficiency is we have to improve, right? We have to improve the fuel efficiency. The lower fuel consumption will be used in the most of the modern technologies, right? So the lower fuel consumption, once we are using the lower fuel consumption, what will happen? The fuel economy will be there, right? So at the same time, the performance will be good, right? So how we can improve our performance, right? So for the turbochargers and the superchargers, right? So that will be help to get them more performance, right, on the CI engines, or sorry, on the IC engines, right? Then the emission standards, right? So it is a major issue, right? So it is a major issue, the emission, right? The pollution, right? So we have to control the emission limit, right? We have to control the emission conditions, right? So it will be in the format of the standardized, right? So now we are going for the BS6, right? Bharat stage 6 vehicles we are manufacturing, right? So that in that manufacturing process, we have to control the emission standards, right? So we have to Students, my screen is visible. Students.
Yes, sir.
Okay, right, fine. எவ்வளோ நேரம் இப்போ லெஃப்ட் ஆயிடுச்சு?
இப்பதான் சார் ஒரு நிமிஷம்.
Okay. Okay, right, fine, fine. So, in olden days, we are using the carburetors. After that, we have some development. So, we are using the port injection fuel system. After that, the research is still going on, right? So, now we are using the GDI technologies, right? So, here you can see the differences, right? So, uh, right. So here you can see first term, the carburetor will be used to mix the fuel and air. Then we have to supply that air fuel mixture into the combustion chamber, right? So that term, that element is called the carburetor, right? So after that, we have some development. So what we have done, we have injected the fuel. We have injected the fuel at the inlet manifold, right? At the inlet manifold, we have to inject the fuel. Then it will be mixed with the air and it will be goes into the combustion chamber, right? So now in the GDI engines, now GDI techniques and the technology, what we have to done means the fuel has to inject in the combustion chamber itself, right? So through the inlet manifold, only the air is supplied, right? Through the inlet manifold, the air is supplied to the combustion chamber, right? So after that, we have to inject the fuel. We have to inject the fuel directly in the combustion chamber, right? So that type of injection is called the direct injection, gasoline direct injection system, right? So then these are the major components we have seen in the last class. So ECU unit is the main term, right? So nowadays we are using the most of advanced technologies. So the ECU unit will be used, right? It is an out of an engine, right? Then it will control all the terms, right? The ECU unit will control the air fuel mixture and the ignition timing, then ideal speeds and the variable valve timings and the electronic valve, that is the injector control will be there, right? So these four are the major terms, right? So where we can get the values, how the EC unit will be works means the EC unit gets the information from the various sensors from the engine. So it will send the signals to the ECU. Then the ECU will gives the instructions, or it will controls the fuel injector, right? So in the fuel injector, we have to supply the high pressure fuel, right, through the high pressure pump, right? So these are the major components. Then we have the plenty of sensors are there. So most probably the acceleration pedal or the throttle position sensor, airflow sensor, then the engine temperature sensor, then the crank position sensor. So we have plenty of sensors here, right? So the ECU unit will get the information from all the sensors and it will be gives direction to the injector drive. Then the injector will be sprays the fuel into the combustion chamber. Then the injector will be the same for the CRDI engine, right? So the same principle will be here also, right? The injector principle will be same for the CRDI engine. Then the multi-point fuel injection system, right? So for the in olden days we are using the multi-point fuel injection system, but now in the recent trends we are using the gasoline injection system, that is GDI system, right? So it will be discussed in unit 2 itself. We can see the multi-point fuel injection system, right? So it will have a separate fuel injector for each cylinders, and it will have the better cylinder to cylinder distribution will be there, and it will eliminate the preheat to the inlet manifold, right? It will, right, these are the inlet manifold, right? So here you can see the different type of the fuel injection. So each cylinder, right, each cylinder will have a separate fuel injector. Each cylinder will have a separate fuel injector. So the it will have the better distribution, right? It will have some better distribution and it will eliminate the preheat of the inlet manifold, right? But in the gasoline direct injection system, right? So I already told that the fuel will be directly injected into the combustion chamber, right? So this type of system is called the gasoline direct injection system, right? So Sorry, am I audible?
Yeah, sure.
எப்போ மறுபடியும் லெஃப்ட் ஆயிடுச்சா?
இல்லை சார் இல்லை சார்.
இல்லை சார்.
இல்ல இல்லையா? ஓகே, ரைட், ஃபைன். Okay, right. So, in the term of the gasoline direct injection system, right? So there, we have to give a particular, sorry, we have to give a perfect fuel injection and the particular amount. It will be metering accurate. So we can get the chemically correct mixture will be obtained. So the combustion will be good in the gasoline direct injection system, right? So in the combustion process, right? In the combustion process, in the case of the GDI, in the case of the GDI, the combustion process is defined as a be taking place in the combustion chamber. So the combustion, the mixing will be occurs in the cylinder combustion chamber itself. The mixing will be occurs, right? The air and fuel will be mixed together, and it will be burns, and we can get the energy and in the combustion chamber itself. So the mixing, formation, as well as the energy conversion will be taking place in the combustion chamber, right? Then the mechanisms are determined by the geometry of the combustion chamber and the inlet manifold, then the fuel injector point, and the moment of ignition, right? So these will be depends on the combustion process, right? So the combustion process will be depends on the geometry of the combustion chamber, the inlet manifold, then the injection point, and the moment of the ignition, right? So these four will be there. So the combustion will depends on these four terms, right? Then the flow of air is generated in the combustion chamber, right? The relationship between the injected fuel and the airflow is extremely very important, right? Extremely very important for that depends the combustion. It depends the combustion, right? So in order to obtain the required charge of the air and fuel mixture, right? So the injected fuel injects the fuel into the airflow in such manner we can mix the fuel in the combustion chamber itself, right? So that we can see, right? So that is the combustion process, right? So here you can see the three terms in a important way, right? So the first term will be the ultra lean burn mode, right? Ultra lean burn mode, right? So why we are using that ultra lean means it's a major characteristics, right? So these are the major characteristics of the GDI engines, right? So the three terms. So one is the superior power will be we can get. So here you can see one is the superior output, right? So the here you can see one is the superior output and the less fuel consumption, right? So these two are the major characteristics of the GDI engine, right? So in the GDI engine, so we can see the one by one, right? So the first one is the ultra lean burn mode or a combustion mode, right? So under the normal driving condition, up to the speed of the 120 kilometer per hour, up to the speed of 120 kilometer per hour, the GDI engine operates in ultra lean combustion mode. So you may remember that one, up to the 120 kilometer per hour, right? So nowadays most of vehicles in the highways we are see the most of vehicles will be going 80 to 120 speed. That is the normal speed of the car, right? So in GDI, at the normal driving mode, normal driving condition will be it's up to 120 kilometer per hour, right? That you can remember, right? So up to this speeds the GDI engine will operate in a ultra lean combustion mode, right? So for the less fuel consumption, right? In this mode the fuel injection occurs at the latter stage of the compression stroke, and the ignition occurs at a ultra lean air fuel mixture ratio. It's of 30 to 40, right? So it will be around 35 to 55 also we are using, right? Around the 35 to 55 also we are using, but on that condition we are using the one more kit, that is the GR, that is the exhaust gas recirculation method will be used for that type of the ultra lean mode combustion mode, right? So due to this ultra lean, so what will happen? Surely ultra lean combustion will be there. So if it is in lean combustion, what will happen? The fuel consumption will be very low, right? The fuel consumption will be very low, right? So here you can see the air fuel ratio. The air fuel ratio will be 30 to 40, right? So here you can see the air fuel ratio will be 30 to 40. But if we are including the EGR unit, that is the exhaust gas removal recirculation unit will be used, means the air fuel ratio will be 35 to 55, 35 to 55. So it is the less fuel economy, it is the less fuel economy. So for that only we are telling that it is the ultra lean combustion mode, ultra lean combustion mode, right? So most of the engine, right? So nowadays most of the engine we are using this type of mode. It will be operates at 120 kilometer per hour, right? You may remember this one, 120 kilometer per hour. It will be act as the ultra mode. Is it clear? Then it will have the superior power output, right? So when the GDI engine operating at a higher loads and the higher speeds, right, the fuel injection takes place during the inlet stroke. This optimizes the combustion by ensuring the homogeneous mixtures, right? Homogeneous charges and the cooler air fuel mixture, that is minimize the possibility of the engine knocking, right? So in that car itself, you can see the intercooler terms will be there. Then the turbocharger terms will be there. Have you seen that notations in that car, backside or front side, anywhere? Have you seen?
Yes,
Right?
sir.
So intercooler or a turbocharger and the notations you may see in the car itself, right? So in the superior power, right? So in the superior power means that is the engine will be operates at a higher load as well as the higher speed, right? So on the time what will happen, we have to optimize the combustion by the homogeneous charges. One is the homogeneous charges. At the same time, the air fuel mixture is minimized possibilities of knocking by cooling the terms, right? We have to cooling the, we have the cool terms, then only we can get the superior output power performance will be there, right? So the engine torque and due to the engine speed, right? So torque, it's based on the heavy loads, right? It is based on the load and speed condition, load and speed condition, right? So you may see the graph, so you may see the graph, right? So what will happen if the engine speed will be increases, engine speed will be increases, so what will happen, the load will be decreases, means the fuel economy will be there, right? So at the same time, so if the engine speed will be increases, the load also will increases, means we can get the superior power, right? So when on the superior power, what will happen, the fuel consumption will be more, right? So the emission also more, so we have to control the emission as well as the fuel. So we have to supply the homogeneous mixture, and the air fuel ratio will be in a cooler term, right? So that we have to supply, right? So these are the combustion modes, right? These are the combustion modes will be there, and these are the major characteristics of the GDI engine also, right? Then the requirements, we have seen the requirements, right? So why we have to use these requirements, the any GDI engine without this requirement, it will not called as the GDI engine, right? So in the last class I briefly discussed, told these terms, right? So why we have to use these requirements of the GDI engine, right? Is it clear? Then you may see how the comparisons, right? It's a comparison for the conventional, that is the older type of engines, and the GDI type of engines, right? So the vehicle acceleration, right? The vehicle acceleration as well as it is the same graph, right? Which we have seen in the superior burning mode, superior output, and the lower fuel consumption, right? So here you can see if the engine RPM will be increases, engine RPM will be increases, right? So up to the the engine RPM will be increases. At the same time, the load also will increases. Means the conventional engine will produce the more, which produce the less power, right? So it will get the power up to the 124 PS, right? Then if we are using the GDI engine, right? So for the same speed condition and same the load condition, we can get the more power, right? So the engine performance will be increases, right? The engine performance will be increases. So it's around 140 PS, right? It's around the 140 PS. Why the engine performance will be increases means we have to optimize, right? We have to optimize the combustion process. We have to optimize the combustion process by the two terms. So one is we have to use, right? We have to use the stoichiometric mixture, right? We have to use the stoichiometric mixture, that is the homogeneous charges will be supplied here, right? At the same time, we have to supply the air fuel mixture in cool condition, right? We have to supply the air fuel mixture in cool condition. Once the intake air temperature will be reduces, automatically what will happen, the engine performance will be increases. So the cooler term also we are using here, so automatically what will happen, we can get the engine performance is high, right? Then the vehicle acceleration, right? Vehicle acceleration, right? So in the multi-point fuel injection system, the acceleration will be high, at the same time the power will be less, right? While comparing to the GDI engines, the vehicle acceleration will be good, right? So these are the achievements of the GDI engines. Then you can see the fuel consumption also, right? So where the fuel consumption will be less, so obviously the GDI engine will consume only the less amount of fuel, right? So for example, in the older engines, right? So if it is an older engine, we are accelerating the pedal, right? So the engine will be runs at 60 kilometer per hour or 80 kilometers per hour. Then only we can get a mileage. Is it correct or not? Then only we can get a mileage for the older vehicles, right? So once the speed will be increases, what will happen? Obviously, we can lose our mileage. But in GDI engine, you can see the up to the 120 kilometer per hour, we are supplying only the ultra lean mixture. So the ultra lean combustion mode will be there, right? So up to the 120 kilometer per hour. So obviously, the fuel economy will be less, right? So the lower fuel consumption will be there in the GDI engine, right? So at the same time, during the ideal condition also, the engine will get the fuel, it's very minimum on the GDI terms, right? So it's around the 40% of fuel will be get reduces, by using the GDI technology. Then the emissions also, by using the catalytic converter, we can remove the hydrocarbon emissions. It's good in the GDI engines. Then, so these are the major advantages, right? These are the major advantages which we are using in the GDI engine. So it will improve the torque. It's around 5 to 10%. It will be increases, and we can get the more power, and it will reduces the NOx condition as well as the hydrocarbon emissions. So it's nearly 20% of emission will be reduces, right? Then it fulfilling the emission requirements also. For the BS6 engines, we are using most of this type of injection system, so it will fulfill the emission norms, right? So here the NOx condition, most of 90% of NOx condition will be reduced here, right? So why? Because mostly the NOx condition will be created, or it will be produces by the unburned combustion of the fuels. But in the direct injection system, the complete burning will be occurs, so we can remove, or we can reduce the NOx conditions, right? So then the fuel power, right? The brake power efficiency also we can improve, and the fuel consumption will be very low, right? So 15 to 20% of fuel will be reduced. So these are all the advantages. So these are all advantages will be there in the GDI engines, right? So is it clear? Is it clear? Students? Students, கேக்குதா?
Yes, sir.
இந்த பிரசன்டேஷன் எப்போதும் தெரியாம இருந்துச்சு உங்களுக்கு, இல்லை தெரிஞ்சுதான் இருந்துச்சா?
தெரிஞ்சுது சார்.
தெரிஞ்சுதா? இங்க திடீர்னு வந்து யுவர் கனெக்ஷன் will be lost அப்படின்னு வருது சிஸ்டம்ல. ஓகே,
இப்பதான் சார் வரல. இப்போ
தெரியல சார்.
இப்போ தெரியல இல்லையா?
yes,
ரைட்,
sir.
ஃபைன். ஓகே, ரைட். Just wait for 2 minutes. I will come back. Great. Anyway, okay, students, am I audible? Right. So now you can see
growing demand for low fuel consumption and stricter emissions limits calls for innovative engine concepts. In 2020, 1/4 of all vehicles worldwide will be equipped with the gasoline direct injection system. Engines with gasoline direct injection create the air-fuel mixture right in the combustion chamber. This results in higher compression, thus improving efficiency. Torque and driving dynamics are increased, while emissions levels are reduced. In combination with surging and downsizing, gasoline direct injection offers the potential of lowering fuel consumption and CO2 output by around 15%. Additional optimizations can be made with functional features such as scavenging and CVO. The Bosch offering for gasoline direct injection comprises coordinated systems technology as well as a comprehensive portfolio of individual components. To supply fuel, Bosch offers the fuel supply module with an electric fuel pump, fuel tank, and medium pressure sensor. These components provide the necessary amount of fuel from the tank right up to the injection. The fuel is compressed by the high-pressure pump to the required pressure level of up to 200 bar and stored in the fuel rail. There, a high-pressure sensor measures the current pressure. Mounted on the fuel rail are high-pressure injectors that meter the fuel and spray it under high pressure right into the combustion chamber. Bosch injectors with innovative laser-drilled spray holes provide maximal flexibility in spray configuration while minimizing wall wetting in the combustion chamber. To achieve the best possible combustion, during gasoline direct injection, the air-fuel mixture is created right inside the combustion chamber. The intake air control supplies the engine with the correct amount of air mass at every operating point. One input variable is the amount of air taken in, which is measured by the hot film air mass flow sensor. Further on, the intake manifold low-pressure sensor measures the air pressure. The throttle body controls the air supply to the engine cylinders by enlarging or reducing the diameter of the intake manifold. The air-fuel mixture requires an ignition spark to combust within the engine cylinder. For this, the ignition coils generate a high voltage of around 30,000 volts, store it briefly, then transfer it as a high-voltage current impulse to the spark plug. Turbocharging enables a larger air mass to enter the combustion chamber. Thus, more air-fuel mixture is combusted, improving performance. The exhaust gas turbocharger uses the energy of the exhaust to compress the intake air. With gasoline direct injection and exhaust gas turbocharger, engine displacement the loss of engine performance results. Optimization of the individual operating points creates engines that deliver low fuel consumption and CO2 output with no loss of performance. Turbochargers require a certain minimum engine speed to attain their charge air pressure. If the speed is too low, a turbo lag occurs. Scavenging is the system innovation from Bosch that works to counteract turbo lag. To this end, the intake and exhaust valves are open simultaneously for a moment. This creates a dynamic pressure differential between the intake and exhaust sides of the engine. Fresh air flows in an exhaust valve towards the exhaust manifold. The increased flow of exhaust gas creates 50% more torque at low engine speeds, counteracting turbo lag. Bosch Engine Control supplies the numerous functions that an efficient engine management system must provide. The driver's wish for more or less an important input variable for the electronic control. The accelerator pedal module supplies the driver's wish as a sensor signal. The crankshaft sensor registers the speed and position of the crankshaft. Additional data is provided by the knock sensor, the temperature sensor, and the camshaft sensor. Exhaust gas treatment from Bosch contributes to compliance with international emissions regulations. The planar wideband lambda sensor and the switching type sensor measure the oxygen content of the exhaust, thus providing the engine control unit with basic information for the correct mixture. Future legislation regarding particulate reduction presents new challenges for combustion engines. With the unique and innovative system solution controlled valve operation, or CVO, for engines with gasoline direct injection, Bosch has successfully employed mechatronics to make a major contribution to achieving compliance with future statutory emissions limits, such as Euro 6 and SULEV. Key components of CVO are the Bosch engine control unit and the Bosch high-pressure injector. Contrary to the conventional pilot-controlled injection, the control unit and high-pressure injector operate in a closed-loop system. During the injection, the control unit measures the activation signal and determines the opening and closing of the valve needle to compute the duration of the open phase. Thus, the electronic control unit can calculate the actual injection amounts of every injection and Meter even the smallest. The precision of the gasoline injection is thus significantly improved in this area and is maintained throughout the working life of the valve, guaranteeing a stable combustion procedure. Gasoline direct injection from Bosch is a key to clean and economical engines, fuel consumption and emissions reductions, as well as increased driving dynamics thanks to
Okay. So this is the working principle of the GDI engine. It an animation பாத்தீங்களா? So எல்லாமே எப்படி இருக்கும்? EC unit போறது, யூஸ் யூனிட்ல இருந்து சிக்னல்ஸ் வர்றது, ரைட்டா? So இதெல்லாம் எப்படி இருக்கும்? GDI ஓட principle, ரைட்டா? So just you can see the YouTube, ரைட்டா? YouTubeலயே நமக்கு இருக்கும், ரைட்டா? So EN Bosch, ரைட்டா? Bosch gas direct injection system அப்படி போட்டீங்கனாலே நமக்கு இது வரும். Just you can refer the video once again, ரைட்டா? So Bosch gasoline direct injection, ரைட்டா? So அது பாத்தீங்கனாலே உங்களுக்கு வந்து ஒரு நல்ல பெட்டர் ஐடியா கிடைக்கும். பிளஸ் ஹுண்டாய் டெட்டா அப்படின்னு இருக்கும், ரைட்டா? ஹுண்டாய் டெட்டா கேசோலின் இன்ஜின் டெக்னாலஜி, ரைட்டா? ஸோ அதுவும் நம்மளுக்கு வந்து ஒரு பார்ட்ஸுக்கான அனிமேஷன்ஸ் ரொம்ப கிளியராகவே தெரியும், ரைட்டா? ஸோ யூ கேன் கோ த்ரூ தட் ஆல்சோ, ரைட்டா? ஹுண்டாய்ஸ் டெட்டா என்ஜின் வித் ஜிடிஐ, ரைட்டா? ஹுண்டாய்ஸ் டெட்டா என்ஜின் வித் ஜிடிஐ, அதையும் நீங்கள் பாருங்கள், ஓகேவா? ரைட். ஸோ அப் டு திஸ் we can finish this class, right? Then the other technology will be discussed in the later classes. Okay. So do you have any doubt in this GDI engine?